Hello, for this informational video, I'm going to break down the concept of windowing and leveling. Window width classically refers to the grayscale, and we have the ability to manipulate our grayscale whether we want lots of grays, so a wide scale, or if we just want few grays, a narrow scale. So with any digital-based image, we have that ability to manipulate that to be able to show us the structures that are of most interest for a particular case. Window level refers to the overall brightness that's being set. Oftentimes in CT images, this is going to correspond to an HU value, a Hounsfield unit value. So when we look down here at this value-based chart, you can see in general, anything that is more dense than water is going to have a positive number, and anything that is less dense than water is going to have a negative value associated with it. Each HU chart may differ a little bit just depending on who is the producer of that chart, but in general here are some corresponding values. So you can see, of course, air is not indicated here, but air is also oftentimes a negative 1000. You can see where lung then falls, the lung-based tissue. You can see that fat is a negative value, and then everything else on this particular scale that's included here is considered to be more dense than water. So cerebral spinal fluid, blood, the tissues of the brain, so white matter and gray matter are indicated here, but also the bony-based structures. So really the goal that I'm trying to go through, I will look at a CT scan of the head and we'll break down what it looks like under a bony-based window, so looking at those cranial-based structures, those facial bone structures, versus what it looks like on the brain window, and how manipulating these values allows us to visualize various structures without having to repeat a scan, for example, and utilize different techniques, but we can just simply manipulate our values post-processing and be able to really visualize those structures that we want. So that is the goal, is just to further break down window width and window level so you can really understand these concepts, and it's not just a definition, but you can actually physically see these changes as they're being made. So what we're currently visualizing here, you can see is a classic brain-based window. So our window width is set at 80 versus our window level is set at 35. So when we look at what we're essentially visualizing here, look at where 35 is and how that corresponds to the HU table. So we're roughly right in between the areas of white matter and gray matter here with our window level. So that's, kind of think about that, is that the brightness that we're trying to visualize is typically going to be relatively consistent with this HU table. So just to kind of look at the structures of visualization here within this, let's start at the superior aspect. And you can see those classic structures. So as we go through the bony-based structures, we're not going to be able to visualize them on this particular window. That's why the top of the cranium, the superior aspect, the parietal bones are not visualized well at all. You can't see any of the bony detail. But as we go through and we start to hit the brain, all right, we can see the brain detail. So this is corresponding to an appropriate window width and window level for visualizing those brain structures. So we can see the area of basically the breakdown of the cerebral hemispheres, right hemisphere versus left hemisphere. We can see the sulci versus the gyrus. We can see the longitudinal fissure in dividing essentially those hemispheres of the brain. So the brain is nice and well visualized. Of course, you can start to see the ventricles coming in. You can see, the pineal gland. You can see the third ventricle, the fourth ventricle. You can see the essentially the midbrain. You can see the cerebellum. So you can see a lot of those structures here on this particular window width and window level settings. But I want to show you essentially what it does as we manipulate things. So looking at this particular setting, I want to be able to better visualize some of the bony-based structures. So what I'm going to do is I'm going to change my window width, and I'm just going to show you what it looks like just changing that component initially. So looking at it, going to 2000 here, look how much more gray the image is now. So let's go back to where we were. Very black and white here at 80. specifically when we look at the structures here of the mastoid air cells. Okay, we have very bright white structures here, the bony processes of the petrous portion, versus very black structures here. But again, let's see what it looks like when we extend our window width, including more grays. Now we're able to really visualize those subtle differences, and you're not seeing that really contrasty based structures, but we're able to visualize the structures a little bit more consistent for how they are here. While this does show us bone, we have to remember that the level also is important. So what I'm going to do is set it at a much higher HU value, 350, to be able to better visualize the bony based trabecula. And when you do that, what you can see here is, yeah, now we can really visualize, same exact scan, but we can visualize the bony based structures so much better in this particular case. So while I did it manually with the window width and window level, there is opportunities to be able to select defaults depending on where you're at. So that's really great when you're looking at a chest, for example, because you can quickly go from the lung to the mediastinum. The defaults here, there isn't a great brain default, so that's why I kind of went with basically the values that I physically typed in there. But nonetheless, typically you're going to be able to visualize multiple structures very easy. So just for fun, let's just click on to lung. So for lung, we know that we should be able to visualize basically the structures, the air-based structures. So when we focus on air-based structures here, for example, in the sinuses, or for example in the mastoid air cells, you can see those structures better. You know, also just note, just in general, how that impacted our window width and our window level. So if we're focusing on the structures of the lung, what just happened? Well, we know when we pull back up our HU table, those lung structures, negative 500 for here on this particular graph, but on this default setting, negative 550, is the ideal setting for looking and visualizing that. So when you think about the brightness setting, we're trying to put the appropriate amount of brightness for a given structure. And window width just pertains to the amount of grays. So had we pulled up a chest-based study, and I will show you another video with a chest-based study, you'll be able to visualize those structures so very much better. But just to kind of get back to the general concepts of, now let's look at the bony-based structures of the head. I'm typing these in, just 2000 by 350 here to visualize those. As we pan through this particular case, we're able to very distinctively evaluate all of the bony-based structures, or visualize all of those bony-based structures extremely readily. As we go basically through the skull, you're able to visualize, you know, those the bony trabecula or the diplo region within that bone. We can definitely be able to visualize that. So you also can see some bony-based articulations here. So just to kind of reiterate, let's show you what 1000 looks like. So 1000, we're like way up there in terms of brightness, but so essentially it's subtracting out all of those other structures. We're not able to see those at all, but when we really look at it, we should be able to visualize the cortical bone at such a high value so much better. But subsequently, we're not able to visualize the cancellous bone or the softer bone nearly as well. So it's important that you have essentially that balance when you're trying to visualize these structures. What happens then if we say, all right, I want less grays? What's that going to be able to visualize? So we go through less grays. Oh my gosh, now it's very contrasty. We're not able to visualize really anything. If we want even less grays, now look at that. We went from 20 to 200, from 200 to 20, even less. Let's just show you, just for the purposes of reiteration, what that looked like again. And you're able to see a little bit more grayness kind of going through this particular region. And let's just slowly step up. Let's hit 500. You see more grays there. Let's hit 1000. You're able to see more grays. Subsequently, you know, it's all dependent on the nice balance of window and level to be able to visualize those given structures of interest. So here, yeah, we can see some of the trabecular markings, but again, as we continue to step up, Let's go to 1200 now. We're able to see those markings a little bit better. So as we're extending our window here, we can be able to visualize those bony base structures better. So hopefully you're a little bit more clear about what this is actually looking like. I don't know if you've been paying attention to this particular graph as well. So essentially this is referring to as the histogram, and the amount of grays that we're setting corresponds to the straight line portion that you're being able to visualize here. So we're setting grays from this point here through this point here. So if I wanted just a little bit more grays, and I want you to watch over here as this manipulation now is taking place. Subsequently, it's changing my straight line portion, so it's basically saying I'm extending the amount of grays to encompass more of the diagnostic information from this point to this point here. Whereas if it was very narrow, it would focus on a more narrow region. So let's go down to 25 and look how straight this line becomes now. So a lot more vertical as we go forward. 25 is nearly vertical, so we're focusing on just a very specific region. So, in essence, hopefully it's a lot more clear at this point, what these manipulations are actually doing in terms of window and level. And while we're looking at CT-based images here, the same concept is present within digital radiography, where we have the ability to extend our grayscale and we have our ability to set our particular brightness factors. So in essence, that is windowing and leveling, and how we have the ability to take one data set, one scan, and to be able to vastly manipulate that information, be able to extend our grayscale, narrow our grayscale, manipulate basically our level. So that's the level is the point at where it's at on the scale. So if we have a scale that's this big, and we want a level that's right in the center, okay, so that level is that center point here. So whatever our scale is dependent on that level, so whatever we're trying to visualize, and then we can subsequently manipulate those values. So the concept hopefully is gonna be reinforced with the following video. So we'll go through one chest exam just so you can be able to see some of the anatomy and some of those structures, and how those structures are better visualized depending on what our actual window width and window level are set at. Thanks.